All right, guys, welcome to your third video lesson on exponents. Today what we're going to talk about are negative and zero exponents. Okay, so as we go through today, we will have to apply the rules we talked about last section, and we're also going to learn some new things, what happens when we have negative exponents and exponents that are zero. So let's take a look. All right, there you go, a little sub-zero for you. Why sub-zero? Because today we're going to talk about negative exponents, exponents that are below zero. So let's take a look here at what we got with negative exponents. So again, let's just kind of quickly review what we learned in the last couple sections. Okay, I have here some powers. We have 2 to the first power. We got to think, what does that mean, 2 to the first power? 2 to the first power is just 2 times itself one time. Okay, so just 2. 2 to the second power means that I'm going to take 2 and multiply it by itself twice, so 2 times 2, that would give me, if we simplify, it's going to give me 4. Okay, and then continuing on to the third power, it's 2 times 2 times 2, that's going to equal 8. And continuing it on from there, we have 2 times 2 times 2 times 2. If we evaluate that, 2 times 2 is 4, times 2 is 8, times 2 is 16. And the last one, 2 times 2 times 2 times 2, one more, times 2, that is going to equal 32. So again, if I evaluate these, this is kind of what powers mean. So notice, as the powers get bigger from 1 to 2 to 3 to 4 to 5, notice what happens to the values if we actually evaluate them. It goes from 2, 4, 8, 16, 32. So what's happening to the numbers, the values, as the exponents get higher, is that the numbers are getting larger. So let's take a second to think about it. What if we go down now? Let's say instead of going 2 to the first, we go lower. Let's say we add in here 2 to the 0th power. Okay, well, what does that mean? 2 to the 0th power. Well, you got to think about, if you look at these numbers, if I go just in opposite order, descending order, 5, 4, 3, 2, 1, well, what happens? As we go down in powers, notice the values are getting smaller and smaller. Now, what are they approaching? Well, as a matter of fact, 2 to the 0th power is simply 1. Okay, so that's kind of the first rule we're going to talk about here today. Anything taken to the 0th power as an exponent of 0 is always going to be evaluated as 1. Okay? So that means if I have, let's say, 4 to the 0th power, that's 1. If I even have x to the 0 power, that's 1. No matter what, anytime you see something to the 0 power, have an exponent of 0, okay, 1. That's always going to be our rule. So notice here that things are decreasing, they're getting to 1. So let's take a guess at what happens when we go lower. So let's say instead of 2 to the 0th power, I go to a negative exponent. Okay, with a negative exponent, we have to think 2 to the 0th power, that's 1. Okay? Now, if we go to a power that's below 1, what's going to happen? Well, you got to look at the numbers here. 32, 16, 8, 4, 2, 1. What's happening? Again, they're getting smaller. If we think about it, what number are they approaching? Well, as they get smaller, they're always going to approach 0. Okay, they're going to get smaller and smaller and smaller, and they're always going to get closer and closer to 0. So this 2 to the negative first power, if we were to take that and punch it into a calculator, what you get is 1/2. Okay, if you have a calculator around, plug in 2 to the negative first power. You get 1/2. Okay, if I continue on, 2 to the negative second power, let's see what we get there. If you have a second, punch it into your calculator, see what you get. You get 1/4. Okay, continuing on, I have 2 to the negative third power. If I were to evaluate that, what I get is 1/8. Okay, so what's happening as we get to negative exponents? Well, let's take a look at what we have as a result. I have 1/2, 1/4, 1/8. Well, what is going on there? 1/2, that's really 1/2 to the first power. Okay, if I condense 1/4, really 4 is 2 to the second power. Okay, 1/8 is 1/2 to the third power. So what do you notice is going on? Well, here we have 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 squared, 2 to the 1st, 2 to the 0. When I throw in the negative exponents now, notice how we have 1/2 to the 1st, 1/2 squared, 1/2 to the 3rd. So can you guys think of a rule? Well, yes. Anytime you have a negative exponent, 2 to the negative third, really what it is that's going to equal 1 over 2 to the third. Okay, well, what happened there? Well, basically the negative exponent, this whole thing, 2 to the negative third, went to the denominator. And what we get is then a fraction. Okay, think of these numbers, 1/2, 1/4, 1/8. They're getting smaller and smaller. So when we have negative exponents, that means things are actually getting smaller. And what happens is we place them in the denominator. Also notice when we place it in the denominator, that third power becomes positive. It was negative here, and now it becomes positive. Okay? And that's a useful trick, because if we don't like to deal with negative exponents or negative things in general, that we can easily make these things positive if we bring them to the denominator. Okay, so that's kind of what's going to happen with negative and zero exponents. So I want you to think about that and use these rules as we go through this lesson. All right, let's try some examples of just simply rewriting the exponents to make them positive. So here I have 2 to the negative third power first. So again, what I want to do is write this as a positive exponent. So notice here I have the negative third as my power. What I want to do is take that and write it as a positive exponent. So what we kind of just said in the last slide, this is really equivalent to 1 over 2 to the third power. So all I have to do is basically take this and put it underneath 1, flip it as a fraction. If you really think of what we're doing here, what are we doing? We are taking the reciprocal. Okay, the reciprocal of this value. So you can also think about that. Okay, next one, x to the negative fifth power. What are we doing here? We want to make it positive, so all we're going to do is take the reciprocal of that, which would be 1 over x to the fifth. Okay, that's going to make these things positive. Okay, 3 to the negative second power, what's that going to be? That's going to end up being 3 to the second power in the denominator, so 1 over 3 squared. Again, we can evaluate this, simplify it a little bit more, but we're just going to write it as an exponent. Okay, last one, a little tricky here. We have 2y to the negative fourth. Okay, you got to be careful with this one. We have the negative fourth power, but what is being taken to the negative fourth power is very important here. Okay, is the 2 being taken to the negative fourth power? Is the y, or both? Well, in this case, notice how there's a lack of parentheses here. Parentheses with exponents are important. So here I have 2y to the negative fourth as opposed to 2y to the negative fourth power. So what's the difference? The difference is, think about our power rule that we talked about. This would mean that my negative 4 is being applied to both the 2 and the y, whereas this means it's only being applied to the y. So this is not what we're going to look at, but instead what we're going to do is take my y to the negative fourth, and I want to make that positive. So the 2 is actually going to stay on top because that has a power of 1 already that's already positive, but y to the fourth we're going to bring downstairs and make that one positive. Okay, so in that case, whatever's positive, we're going to leave where it is, and negative exponents, all we're going to do is flip them, put them in the denominator, or take the reciprocal to make them positive. All right, we're going to throw a little extra sass here. Now what we're going to do is simplify, and our end result, we're going to make only the things positive, okay, only the exponents positive. So this is going to apply some of the rules we talked about in the last section and what we're going to talk about today. So again, anything that has a negative exponent, we want to make them positive. We're going to take the reciprocal, meaning we're going to flip it and put it over 1. Okay, so look at number 1 here. I have 2x squared, y to the negative third, z to the second power. So right away you notice y to the negative third. This right here is the only one with a negative exponent. So if I want to make it positive, all I'm going to do is take the inverse. So basically take it from the numerator and you place it in the denominator. So I have 2x squared, z squared. I'm going to leave those on top because they're all positive exponents. And then I'm going to take y to the third and bring it below. Okay? Again, because y to the negative third is the same thing as saying 1 over y to the third. Okay? So again, all I did was put in the denominator. This right here is simplified. Okay? I can't simplify the x's and the y's together or the z's and the y's together because they're different variables. All right, number 2. Again, negative exponents. I see a to the negative second, c to the negative third. Okay? So breaking these down, I guess a to the negative second is going to equal 1 over a to the second. C to the negative third is going to equal 1 over c to the third. So what I'm going to do is just combine all these things. So I have 1/4 times, instead of a to the second, I'm going to have 1 over a to the second, times b to the fifth, that's going to all simplify out, times 1 over c to the third. Now when I multiply all these things together, okay, what I have is 1 times 1 times b to the fifth. You can think about this as over 1 times 1. So what does that simplify out to? Well, I just have b to the fifth up top. Below now I have 4 times a to the second power times 1 times c to the third. Combining those, I get 4 a to the second, c to the third. I'm going to leave the 1 alone. Normally don't write those, so that's simplified. Now what did I do differently in this example that I didn't do in the last example? Well, notice how I took every term and I separated them. Where they had negative exponents, I rewrote them, and then I combined. So again, go back to the first lesson we did with expanding and condensing, kind of doing the same thing here. All right, let's take a look at the next two examples. Okay, now these ones are going to apply some of the rules we had before, so what I want you to do, okay, think back to last section. I want you to pause the video right now and see if you can simplify these next two examples. Okay, again, I put GEMDAs there so you can think about the rules that we talked about, the product rule, power rule, and the quotient rule from last lesson. So give these one a shot. Ready, set, go. All right, let's take a look at what we have. So, first example, 3x to the negative third power, y to the 0. All that's being squared or taken to the second power. So again, here I'd use my power rule. Again, I'm going to take this power, I like to think of it as distributing. So I'm going to take this power of 2, distribute it to the 3, the x to the negative third, y to 0. So here I expanded it out, showed it like this. Okay, now I used my grouping, my exponents. Now let's think about what happens here, okay? I'm going to take my exponents and I'm going to multiply them together. So the product rule, exponents you're going to multiply. Okay, so I'm taking a power to a power. So that means x to the negative third to the second power, I am going to multiply those. Negative 3 times 2 is negative 6. 0 times 2 for the y is 0. So I'm left with this. Now I evaluate. 3 squared, that's 9. Okay, x to the negative 6, that's a negative exponent. I rewrote that. 1 over x to the 6. Y to the 0, well, hey, anything we set to the 0th power, this is our rule we just have to remember. Anything to the 0th power is 1. So I can just drop that y and write it as a 1 over 1. Then I combine all the tops. 9 times 1 times 1 gives me 9. 1 times x to the 6 times 1 gives me that. There's my answer. Okay, next one's a little more challenging, okay? Here's what I did now. There's multiple ways in which you can do this to start, okay? So I did this a different way. What I did is I took my negative exponents and I made them positive by rewriting this as 1 over m to the third and 1 over n to the fifth. And what I then did is you can think of all these as being multiplied together. I multiplied all the numerators, 2, m to the fourth, n, 3, 1, and 1. Okay? Now I didn't do it here, but really 2 times 3, that's going to give you 6. So I did that at the very end. But then I have m to the fourth on top, m to the third on the bottom. Then I have n on top, n to the fifth on the bottom. So all I had to use here was then my division rule. I have a quotient I'm dividing. That means I'm going to subtract. So 4 minus 3, that's m to the first. This one is n to the first minus n to the fifth, so that's 1 minus 5. Now this one's tricky. I kind of skipped over the step, but n to the 1 minus 5 is actually n to the negative fourth, which that's going to equal 1 over n to the fourth. So notice here how I end with n to the fourth in the denominator. Okay, so negative exponents is a little tricky here, but notice how I can apply all my other rules we learned before. Okay, I want you guys, again, do these ones. I have a little more complicated problems. Again, I'm going to apply our rules, but I want you to solve these two using your rules of exponents and what we talked about, negative exponents and zero exponents. So give these two a shot. Ready, set, go. Okay, let's see what you got here. So the first one, let me show you how I simplified. Started with 4 over 2. I simplified that. Treat numbers like numbers. Remember that rule. Treat numbers like numbers. 4 over 2. 4 divided by 2 is 2. Then I applied my division rule. Okay, my quotient rule. X to the second power divided by x to the fifth. What I'm going to do is subtract those. So 2 minus 5 is negative 3. So I get x to the negative third power. The y's, I have negative 3 divided by 2. So I show this on the right here. It's negative 3 minus 2. So what is that? That is not negative 1. But instead, that's going to be y to the negative fifth. So I just rewrote that there. Then again, what I did is separate everything. So I wrote as 2 over 1. Z to the fourth, I wrote 1 over z to the fourth. X to the negative third, I rewrote as a positive exponent, put it in the denominator. Same thing there with the y to the negative fifth. Okay, then I just multiplied across. 2 times 1 times 1 times 1 is 2. And then for the z's, x's, and y's, I wrote them all multiplied together. I can't simplify those because they're not the same base. Okay, so that one's that. Now, next one's actually simply, look, I kind of showed my work here, but you have 2xy to the 7th to the 0th power. So I used the product rule, or sorry, the power rule, and I distributed the 0 to each term, shown here, and 2 to the 0th power here. So you got to remember, anything to the 0th power is 1, so that's 1. That's 1. This, I simplified using the product rule again. Y to the 7th to the 0th power. Okay, that one's y to the 0, that's 1. So in the end result, I get 1. A lot more simpler than it looks. All right, Boss Hogs, last example here. This one's nasty, so I want you to give this one a shot. Pause. We have a big one. Ready, set, go. Okay, hopefully, let's see what you got. This one is a doozy, guys. Okay, so let's see what we got. All right, what I did, first of all, I see grouping here. So I took this and I saw 2xy to the 4th was taken to the 3rd power. So I applied the product rule here. I took that power of 3 and distributed it to each term. Made a little boo-boo here, but we have 2 to the 3rd, x to the 3rd. I kind of wrote the 4th. And then y to the 4th to the 3rd. And then I wrote everything else. Okay, then all I did is simplify then. So I took 2 to the 3rd is 8. So I wrote that out, 8. Okay, x to the 3rd I left alone. Y to the 4th to the 3rd power, again, that's a power to a power product rule, or sorry, power rule. I'm going to multiply 3 and 4 to get y to the 12th. Okay, then I had everything else written out the same. Now here's what I did. Notice on top and bottom I had x to the negative 3rd and x to the negative 3rd. Yeah, I could make those positive, but notice how I have the same thing on top as the same thing on bottom. Okay, if you think, if I had 4 over 4, what happens to those things? Well, that equals 1. They cancel out. If I had x over x, we talked about that. These two things cancel out to give you just 1. All right, so we kind of have that same rule going on here. Doesn't matter if there's negative exponents. They're the same thing. I cancel them out. Okay, then I rewrote, or took, sorry, it's also simplified. 8 over 4 is 2. So I rewrote that over here. 8 divided by 4 gave me the 2. I had x to the 3rd, y to the 12th. And then I had 3y squared left over. And on bottom, all I had left was y to the 0th power. So here's what I simplified next. Y to the 0, well, that's just 1. So really my denominator is 1, so I don't have to write this as a fraction anymore. 2 and 3 I combine. 2 times 3 is 6. X to the 3rd, rewrote that. Y to the 12th, y squared. Then last thing, y to the 12th times y squared, same base, different powers, multiplying them together. You can apply the product rule this time, set it right, to give me y to the 14th, because with the product I add the exponents. And this, folks, believe it or not, no, I don't mean Ripley's believe it or not, but that is your final answer, and that one you can stand up and wipe the sweat off your brow. Okay, that concludes this lesson. Hopefully you enjoyed it. We'll see you in class.